Hi, my name is Charan Agnihotri, and today I'll be presenting Lab 3 Black Hole. The problem we're trying to solve is finding the net force on a star by a black hole of unknown mass. In addition, we're also trying to find the mass of this black hole. In theory, if we know the motion of an object, we should be able to find the net force on this. This is made possible by Newton's second law of motion and Newton's law of gravitation. Throughout this presentation, I will show you the experimental setup, the GlowScript code, my GlowScript model, and then discuss the model and end with the conclusion. The experimental setup involved a GlowScript model with a star moving around a black hole. The seed was set to my email. The mass of the star was set to 2.0 times 10 to the 30th power kilograms. The gravitational force of the black hole was the only force acting on the star, and the star completed one full rotation around the black hole. In this code, I compute the initial and final momentum vectors by multiplying the mass of the star by the initial and final velocities. Then I also use these initial and final velocities to calculate the momentum and the delta V and delta P. With the delta P, I was able to calculate dP dt and use that to calculate the net force. Using p hat, I was able to calculate the delta of the magnitude of dt, and then use that to calculate the parallel forces and the perpendicular forces. Continuing the GlowScript code, here's I set the mass of the star to 2.0 times 10 to the 30th kilograms, and delta t to be the amount of time in a day in seconds. I used Newton's law of gravitation rearranged to find the mass of the black hole, and I used an error scale of 10 to the negative 17th to formulate my arrows. Here's a recording of my GlowScript. Using the 430 data points of the magnitude and net force given by the model in my calculations, I calculate an average net force of 1.83 times 10 to the 29th newtons. Using this net force in conjunction with Newton's law of gravitation, as I explained in my GlowScript code, we can calculate the mass of the black hole to be 9.64 times 10 to the 33 kilograms. What does it mean? Net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular components, even though they might seem the same at first glance. The net force is the sum of all forces applied to an object, and its parallel and perpendicular components are components that are acting in the parallel and perpendicular directions. The rate of change of momentum, on the other hand, is the change of momentum over the change of time. While this may seem the same, it's different in that instead of forces acting, it's what the object's doing, and its parallel and perpendicular components are components changing in the parallel and perpendicular directions. Now, what if the black hole was replaced? If object was affected by the new force, the motion would change, and in turn we can use this change in motion to find the new net force, and we can find this new net force to find the new mass of the new black hole. However, if the motion did not change, we would not be able to determine the new net force. As a result, we would not be able to determine the new mass of the black hole. In conclusion, if we know the motion of an object, we can calculate the net force. This is done through Newton's second law of gravitation, Newton's law of gravitation, and Newton's second law of motion. Using these, we can form accurate models in order to accurately predict net force and motion. Thank you.